In this video on algebraic division and finding factors, we're going to look at how to fully factorize an algebraic expression so that it can be written as the product of several other expressions without anything left over. Again, this can be very useful for solving equations, for example. So here we have in question 1 a cubic equation, or rather a cubic expression, where the highest power of x is x cubed, and we're told that it divides exactly by x minus 5 because x minus 5 is a factor. So we're going to find out what the other factor or factors are by a process of division, and this is how it works. Okay, so I start by writing down the question number there, 1, and then I write down what we call the divisor, which is the thing that we're dividing by, which is x minus 5. Okay, and I'm seeing how many times x minus 5 divides into x cubed minus 6x squared minus x and plus 30. Okay, and I'll talk you through the steps, and then I'll show you another way of doing this in the second question, but we'll start with this. Now, x minus 5, how many times is it going to x cubed minus 6x squared? Now, all I need to look at is the first part. How many times does x go into x cubed? And the answer is x squared. Okay, and then I say, okay, x squared times x does give me the x cubed, and x squared times minus 5 gives me minus 5x squared. Okay, so I see what's left over by doing a subtraction. Now, if you've done long division with numbers, this process is very similar. So I now say, what's the difference? Minus 6x squared take away minus 5x squared is the same as minus 6x squared plus 5x squared, which is minus 1x squared. So it's just minus 1x squared. And then I bring down the next term, which is minus x. And I ask the question, how many times does x minus 5 go into minus x squared minus x? Well, it's a strange concept to think of that, but we just look at the first term. How many times does x go into minus x squared? Well, x goes into x squared x times, so it goes into minus x squared minus x times. Okay, because minus x times x is minus x squared, and minus x times minus 5 is plus 5x. Okay, plus 5x. And then we do the subtraction again, and we have this time minus x take away 5x, which is minus x take away 5x is actually minus 6x. Okay, and then we bring down from the top the 30, and we say, how many times does x minus 5 go into minus 6x plus 30? Well, x goes into minus 6x minus 6 times. Okay, and minus 6 times x is minus 6x, and minus 6 times minus 5 is plus 30. And then we do the subtraction to see what's left over. Now, at this point, we would expect 0 and 0, which we've got. In other words, no remainder. And the reason we expect that is because we're told that x minus 5 is a factor. You see, if it wasn't a factor, then it wouldn't divide exactly into that, and there would be a remainder. Just let me give you an example with a number. If I said, is 4 a factor of 24? Well, the answer is yes, because 24 divides by 4 with no remainder. But if I said, is 5 a factor of 24? Well, the answer's no, because if I divide 5 into 24, it goes 4 times, but I get a remainder. So it's not a factor. But this is a factor, and if I'm told it's a factor and I find there's a remainder here, then it means I've done something wrong in the division. So what does this actually mean? Well, if I just call this function here f of x, okay, so that saves me writing it all out again. So this thing here in red is f of x. Then I can say that the function f of x can be expressed as the product of two factors, and the two factors are the given one, x minus 5, multiplied by the quotient or the answer to our division, which is x squared minus x, okay, minus 6. Now at that point you look at what you've done and ask the question, can it be factorized further? Now you've got a linear factor here, that's one where the highest power of x is 1, and a quadratic factor here. And the question is, can that quadratic be further factorized? In other words, are there a pair of numbers that multiply together to give minus 6 and add together to give minus 1? Well, there are. They are minus 3 and plus 2, because if I multiply minus 3 and 2 together, I get minus 6. If I add minus 3 and 2 together, I get minus 1. So the complete factorization of the original cubic expression is this. The implications of this are really useful. So if I can factorize a cubic expression fully like that, if I were to solve the equation f of x equals 0, in other words, I want to find the values of x that cause that expression to equal 0, then by factorizing it, I can see the three answers straight away. Because if this whole thing has to equal 0, either x can be 5, or x could be minus 2, or x could be 3. And over here, I've done the graph for that function. And there it is. And you can see that the three places where the cubic graph crosses the x-axis are when x is minus 2, causing this bracket to be 0, or 3, causing this bracket to be 0, or 5, causing this bracket to be 0. Okay, so that's one of the main uses of factorizing expressions. Now, in the next one, I'm going to do the same kind of process, but there's a couple of things that I'm going to do differently. But the first and most important thing to notice in question 2, I'll do this one in blue, is that the terms in this expression are in the wrong order. They have to be arranged where the highest power of x is first. So x cubed, x squared, x, and then the number. All right. It's a bit like taking a number and changing the position of the tens, hundreds, thousands, digits, and it would be a different number. So we must get them in the right order. So for question 2, the first thing I'm going to do is I'm going to call it, this time I'll call it g of x. That's the function I'm given in blue there. And g of x, I'm going to rearrange rather to make x cubed at the front. So I've got 2x cubed. Then I have my x squared term. Okay, then my x term, and then the number on its own. And it's very important that you do that first before you proceed any further. Okay, now I can do the division. But what I'm going to show you this time is a little kind of shortcut really, by taking out all the algebra from it and just dealing with the numbers. So I'm told that x plus 3 is a factor. Okay, so that means it will divide exactly by x plus 3. But I'm not writing x plus 3. I'm just going to write this 1x plus 3. And I'm going to divide that into 2x cubed plus 1x squared minus 13x plus 6. So I've written the coefficients down, but not the actual algebra. And it's a lot easier to see what's going on with the actual division process. So I now say 1, 3 into 2, 1. I don't say how many 13s go into 21, like numbers, because it's not. It's 1, 3 into 2, 1. And I look at just the first term. How many times does 1 go into 2? It goes twice. Okay, but then that gives me 2 times 1 is 2, and 2 times 3 is 6. So what's left over I get by subtracting, and 1 take away 6 gives me minus 5. Okay, and obviously that's going to be 0. Now I bring down the 13, or the minus 13, and that goes there. And I say, how many times does 1, 3 go into minus 5, minus 13? I just look at the first term. How many 1s go into minus 5? Minus 5 times. Okay, but what is that? Minus 5 times 1 is minus 5, and minus 5 times 3 is minus 15. Okay, do the subtraction to see what's left over. Well, I've got minus 13. Be very careful here, because it's minus 13 take away minus 15, which is the same as minus 13 plus 15, which is actually 2. Bring down the 6 and do the final stage of the division. 1, 3 into 2, 6 goes exactly twice, because 2 lots of 1, 3 make exactly 2, 6. And no remainder. And that's what we expected, because we were told that x plus 3 was a factor. So therefore we knew it would go exactly, and there shouldn't be a remainder, which of course there isn't. So we've done the same process as we've done here, but without writing down the x cubes, the x squareds, and the x's and so on. So what I'm actually saying here is that this expression g of x can now be written as x plus 3 times the quadratic part, which is 2x squared. Okay, this is how you interpret this, minus 5x plus 2. Okay, and then we do the same as we did last time. We look at the quadratic part and see if that factorizes. Now it does, but it's a bit more tricky this time because of the 2x in front. So we know that 2x and x are how the two brackets would have to start to give us the 2x squared. Okay, so we start with that. And then we're looking for the remaining factors from that. And it will be minus 1 and minus 2. Okay? If you took those two brackets together, those last two brackets, and multiplied them together, you'd get this. Minus 1 times minus 2 is plus 2. And I've got the outer and inner terms. The outer term would give me minus 4x. And this would give me minus 1x, which is minus 5x, you see. And the 2x times the x would give me the 2x squared. So it's a little bit more difficult to factorize that one, but it's there. And so that is the full factorization of the second of these questions, g of x. Now, on the third one, okay, I'll do this one in green to match the color there. This time, we notice that we have an x cubed, an x, and a number, but we don't have an x squared. And this is the most common mistake. Because if you had a number that had thousands, hundreds, tens and units, then you would be writing a 0 in the hundreds column, because you've got like the thousands is the x cubed, the hundreds is like the x squared term, and there isn't one, so it would be 0. So what we would need to do is write this function h of x, I'll call it, okay, like this. So I'm just going to write this here for number 3. Okay, so h of x is actually going to be equal to x cubed, and then I'm going to have to put plus 0x squared. Okay, then I can put my minus 2x, and then I can put my plus 21. So everything's in the right order, but we're missing the x squared term because it's 0. So when I come to do my division, my factor is x plus 3, the same as the last one, so it's 1, 3, okay, but it's 1, 3 dividing into 1, 0, negative 2, and 21. Okay, so there's my 4 coefficients, including the missing x squared term. And then I do the same thing I did up there, the same process. So 1, 3 into 1, 0 goes once. 1 times 1, 3 is 1, 3. Subtract 0, take away 3 is negative 3. Okay, bring down the next number, which is minus 2. Okay, then I say, how many times does 1, 3 go into minus 3 minus 2? Just look at the first number. How many times does 1 go into negative 3? It goes negative 3 times. Okay, which makes negative 3, and negative 3 times 3 is negative 9. Do the subtraction again, see what's left. Okay, minus 2 take away minus 9 is minus 2 plus 9, which is 7. Okay, bring down the 21. We expect it to go exactly with no remainder. Well, it does. 1, 3 goes into 721 exactly 7 times. If I do that, 7 times 1, 3 is 721, and we can show yet again no remainder because it's an exact division there. Okay, so we know that h of x can now be written as x plus 3, and that is multiplied by x squared minus 3x, okay, plus 7. All right, now we look at the quadratic to see if it will factorize, and in fact there are no factors of 7 that add up to negative 3, but further to that, it's not even possible to solve that quadratic at all. Now that has an interesting implication with the graph. Okay, it means you can't factorize this any further, so that's the answer to the question, all right, where it says fully factorize. We've now done that, but let me show you what the graph of y equals x cubed minus 2x plus 21 looks like, and now you might see why it can't be further factorized. So if I just pull this in here, okay, so you can see it. Okay, now there is the minus 3, which comes from making the bracket x plus 3 into 0, so x is minus 3, but the curve doesn't then cross the x-axis again anywhere, which means there are no further solutions and no further factors that can be deduced from this. Okay, so that's an interesting connection between a quadratic that won't factorize and the graph. Okay, so that's an introduction to the algebraic division process. There are other completely different ways of dealing with this kind of problem. Okay, and one of them involves equating coefficients, which we'll look at in a different video. Okay, so I hope that was helpful. Take care.